Hi, I welcome all of you for the today's GATE class. Myself Dr.P.SASIREKA, working as Assistant Professor in Engineering College, Chennai. Now, today's topic is combinational circuits. Now, I will explain what is a combination circuit. So, combination circuit is a circuit whose present output always depends upon the present states of the input. It does not require any memory elements. Sequential circuit means the present output always depends upon the present input as well as the previous output. In order to store the previous output, we need a memory elements. But in the combination circuit, there is no need for any memory element because its output always depends upon the present states of the input. Next, so had listed the some of the combination circuits, that is half adder, full adder, half subtractor, full subtractor, multiplexer, demultiplexer, encoder, decoder, magnitude comparator, all are examples for the combination circuits. So I am going to discuss about the problems based on the multiplexers. So first I will explain what is multiplexer. So multiplexer is a combination circuit which is having the n input lines and only which is having the n input lines and only one output lines. It depends upon the number of selection lines, the output will be displayed. That is here the selection lines will be here. So depends upon the selection line only, any one of your input is connected with the output. Okay, multiple input into single output. This is the concept of the multiplexer. So depends upon the selection line, any one of your input is connected with the output. Okay, this is the first problem we are going to discuss. That is, I will read out the problem. In the circuit shown below, P and Q are the inputs. The logical function realized by the circuit shown in below is. Here there are list of options. We have to choose the correct options. So this is nothing but the 2:1 multiplexer. That is, there are two inputs, only one output line will be there. So there is only one selection line. So to the power of n inputs, only one output, there is a n selection line. So two inputs means this I0, I1 are the inputs, only one selection line, that is a Q, only one output, that is Y. So depends upon the selection line Q, either I0 or I1 will be connected with the Y. So if your selection line Q is equal to 0 means I0 is connected with the Y. If the Q is equal to 1 means I1 will be connected with the Y. So first we can write the output equation for this multiplexer so that you can easily find out the answer. So here the I0 is connected with the ground. So this is equal to 0. So here I1 is connected with the P. So we have to write the output equation Y is equal to, if the selection line Q is equal to 0, I0 will be connected with this Y. If it is Q is equal to 1, I1 will be connected with the Y. So you can write the output equation as I0 Q bar plus I1 into Q. If your Q is equal to 0 means I0 will be selected, Q is equal to 1 means I1 will be selected. So here this I0 is given as the 0, it is connected with the ground, so this I0 value will become 0. So 0 into Q bar plus I1 is nothing but P. So P into Q. So your output is equal to 0 into Q bar is nothing but 0. So you can get output equation as P into Q. So this is the correct answer. So the option A is the correct answer. Y is equal to P into Q is the correct answer. So multiplexer is nothing but it is having the multiple inputs, only one output. Any one of your input is connected with the output, depends upon the selection line given. So for answer for this question, Y is equal to P into Q. Okay, now we will move on to the next question. Okay, this is the second question. Consider the multiplexer shown in the figure. For output to be the XOR of the C and D, the values of A0, A1, A2 and A3 are. Okay, there are 4 options are here. So this is the multiplexer. Here we are using the 4:1 multiplexer. 4 inputs, only 1 output line. So if there are 4 inputs, mean there will be the 2 selection lines will be here. The S0 and S1 are the selection lines. So that depends upon this selection line values only, any one of your input is connected with the output. If the selection lines are S1, S0 or 0, 0 means A0 will be selected. If it is a 0, 1 means A1 will be selected. If it is a 1, 0, A2 will be selected. If it is a 1, 1, A3 will be selected. A3 will be connected with your output. So further, so we can write the output equation for this multiplexer. First, the output of the multiplexer F is equal to, if the already told you, if the selection line both are equal to 0 means A0 will be selected. So we can write the equation as S1 bar S0 bar into A0 plus, if it is a 0, 1 means A1 will be selected. So S1 bar S0 into A1 plus, if it is a 1 selection line is a 1, 0 means A2 will be selected. That is S1 S0 bar A2 plus, if both the selection lines are 1 means S3 will be selected. S1 S0 into A3. So in the S1 bar S1 and S0 are named as C and D, so that you can write S1 bar as a C bar, S0 bar as a D bar. C bar D bar A0 plus C bar D A1 plus CD bar A2 plus CD A3. But in this question they had given F is nothing but the XOR of C and D. XOR of C and D means the output is nothing but the C D bar plus C bar D. So in this output of this multiplexer, you have to get only the C D bar plus C bar into D. So it means that your A0 and A0 and A3 will be 0, A1 and A2 will be 1. So the option, the input of the multiplexer are A0. If it is A0 is equal to 0 means this term will become 0. If A3 is equal to 0 means this term will become 0. So you can get only the output as C bar D plus CD, because A1 is equal to 1, A2 is equal to 1. So you can get the output as C bar D plus CD bar. The question itself they had mentioned the output is nothing but the XOR of C and D. So this is the answer. A0 is equal to 0, A1 is equal to 1, A2 is equal to 1, A3 is equal to 0. So the option C is the correct answer. Option C is the correct answer. Okay, next question is a half subtractor question. That is, in a half subtractor circuit with X and Y as the input, the borrow and difference are given by, there are 4 options are there. So half subtractor, it is a combinational circuit which is used to subtract 2 binary values. The outputs are difference and borrow. So borrow and difference are the output of the half subtractor circuit. So for a difference is equal to difference is equal to n, denoted by n. So n is equal to inputs are x and y. So input n is equal to x XOR with y is the equation for the difference. For the borrow, m is equal to, borrow is denoted as m is equal to x bar into y. So the option C is the correct answer. That is, n is equal to x XOR with y, borrow is equal to x bar into y. So difference and borrow. This is the output equation of the half subtractor circuit. So half subtractor. So I will just a minute. I will draw the half subtractor circuit so that it is easy for you to understand the outputs. X and y are the inputs of the half subtractor circuits. So the difference is given as n. This is n. So borrow is nothing but m. So this is the circuit of the half subtractor. N is nothing but the difference, m is nothing but the borrow. So n is equal to x XOR with y. But if borrow is equal to, m is equal to x bar into y. So this is the answer. The option C is the correct answer. So next we will move on to the next question. So it is also based on the multiplexer only. Consider the multiplexer based logic circuit shown in the figure. Which of the following Boolean function is realized by the circuit? So there are two multiplexers are given. Both the multiplexer are 2:1 multiplexer. So two inputs, one selection line, one output. So here also two inputs, one selection line. The output is nothing but the F. So the input for the first multiplexer is denoted as a W. So there are four options are given. So based on that, based on the input, we have to write the output equation F. So here the W is given as the input. So if it is given to Z, directly is given to the first input, that is W. Here we are using the NOT gate. So if the W is the input for the NOT gate, mean W bar is the output. So it is connected with the selection line S1. Then it is given to the second multiplexer. The output of the first multiplexer is given as the input for the second multiplexer. So first we can write the output equation of the first multiplexer. So depends upon the selection line only, output will be uptime. So if it is S1 is equal to 0 means W will be correct. 0 is connected with the output. If it is a 1 means 1 is connected with the output. So that's the output. Let this output as the X. X is equal to W S bar plus a W bar into S1. This is nothing but the W and S1 are XOR gate. So we can write X is equal to W XOR with S1. Next, it is given as the input for the second multiplexer. So X is given to the input for the second multiplexer, that is given to the I0. This X here we are using the NOT gate. So X bar is given as the input for the next multiplexer. Here we are using the selection line as a S2. So if now we have to write the output equation F. F is equal to, so here where S2 is the 0 means X, and this X is connected with the F. S2 is equal to 1 means X bar is connected with the F. Now we can write F is equal to X into S2 bar plus X bar into S2. It means that both are XOR gate with each other. So we can write X XOR with S2. So we know that X is nothing but the W XOR with S1. The answer is W XOR with S1 XOR with S2. So the option D is the correct answer. Okay, next question. Next question, it is the logical function implemented by the circuit S. The circuit is given. So we have to write the output equation. Here we are using the 4:1 multiplexer. There are two selection lines. These selection lines can be named as P and Q. So it depends upon this P and Q value only the N of your input is connected with the output Y. So first we can write the output equation. Here we are using two NOT gates. First, the ground, here we are using two NOT gates. The ground is connected with the NOT gate. So the ground is nothing, means we have to, here the input is nothing but the 0. It is given to the NOT gate. So for the NOT gate, if you are giving 0 as the input means 1 is the output. So 1 is the output. If you are giving 1 as the input for the next and a NOT gate means the output is nothing but the 0. So your I0 is connected with this NOT gate. So pi naught value is equal to 0. This I1 is connected with the here. So that is 1. I1 is equal to 1. I2 is equal to 1. I3 is connected with this. So this is nothing but the 0. So your I0 is equal to 0. I1 is equal to 1. I2 is equal to 1. I3 is equal to 0. So depends upon your P and Q value. Depends upon the selection line. I0 or I1 or I2 or I3 will be connected with this output. So now we can write the equation. Zero, 1, 0. So your output Y is equal to, if your P and Q both are 0 means I0 is selected. So we can write P bar q bar into I naught plus, if it is a 0 1 means I1 will be selected. 0 1, that is p bar q into I1 plus. If it is a 1 0, I2 will be selected. That is, you can write p q bar I2 plus. If both are 1 means I3 will be selected. That is P and Q is equal to I3. Now we can substitute the values of I0, I1, I2, I3. So here this I0 value is equal to, I0 value is nothing but 0. Suppose 0 into P bar, Q bar, I1, I2 both are 1. So you can write 1 into P bar Q plus 1 into P Q bar plus I3 is equal to 0. So 0 into PQ. So the 0, this term will become 0, this term will become 0. You can get only the P bar Q plus PQ bar. This is nothing but XOR of P and Q. So the answer D is the correct one. Next question, it is also based on the multiplexer only. For all these questions, we have to write the output equation. So in the consider the circuit shown in figure, we have to write the output equation F. The 4 options are given. So there are 2 multiplexer. So we have to write the output equation for this multiplexer. Here 0 and 1, so depends upon the selection line only, the output will be connected with this, connected with the output. So if it is a 0, if the x is equal to 0 means y will be connected. If it is a x is equal to 1 means 0 will be connected with the output. So if you are writing the output equation, you can get the correct answer. That is, if you are I will solve this problem. So here y is a 0, so this one is a x, this is 0 z. So if your x value is equal to 0 means the y is connected with this output. So you can write here x bar into y plus, if the selection line is equal to 1 means that is x into this 0. So this x into 0 will become 0. So the output is nothing but x bar y for this multiplexer. This is given as the input for the second multiplexer. Here we are using the NAND NOT gate. So the output of this NOT gate is nothing but x bar y to the whole bar. So one of the input is x bar y, another one input is x bar y to the whole bar are the inputs for the second multiplexer. This is the second multiplexer. Here the input is 0, this one is 1. This one is 0, this one is 1. So you have to get the output. This is a 2:1 multiplexer. Now we can write the output equation of this F. F is equal to, if it is the z is equal to 0 means this one will be selected. If it is a 1 means x bar y bar to the whole bar is selected. So now we can write z bar into x bar y plus z into x bar y to the whole bar. So the answer is equal to x bar y z bar x bar y z bar plus here x bar y x bar y to the whole bar means we can apply the De Morgan's theorem. If you apply the De Morgan's theorem, this term into z, if you are applying De Morgan's theorem means this term will become x double bar plus y bar. X double bar means bar get cancelled each other. into z. So x plus y bar z. Already we are having one more term, that is x bar y z bar, x bar y z bar. So all are equal to your output equation f. So you can write f is equal to x bar y z bar plus x z plus y bar z. So just look at the options. X bar y z bar plus x bar y z bar plus x z plus y bar z. This option B is the correct answer. So for all this multiplexer question, first we have to write the output equation. So from that you can easily find out the answer. Thank you.